Today we will see what is the rule of exponents. Now the main idea here is that when you multiply two expressions and they have the same base, so when you're multiplying, you're going to be adding the exponents. And when you're dividing and they have the same base, you're not going to add the exponents, but you're going to subtract them. Let's get some examples. Multiplying, addition of exponents, dividing, subtraction of exponents. So here's our first example here. Let's try to simplify the following. Now, notice that what you're really doing here is that you're multiplying. You have two expressions that are multiplying. Both of them have the same base. Both of them are x's. So what can you do with the exponents? According to the rule of exponents, you can have the same base, and then you can add the exponents. So now that becomes x to the 11th power. And that's pretty much it. If they're multiplying, you're going to add the exponents if they have the same base. Let's look at the second example here. Notice, same base. Both of them have base 2. They're multiplying. So what we're going to do is we're going to add the exponents. So now this becomes 2 to the 4 plus 2, which becomes 2 to the 6. You can find this number in the calculator, 2 to the 6, but we're going to leave it right here because we're just concentrating on the rule of exponents, not so much of the numerical representation. Multiplying, you add the exponents. Let's look at our third example here. First thing you need to ask yourself, do they have the same base? Yes. Okay. But now notice that this time we have numbers in front of those variables. So what we do in this case is, well, you're going to multiply the numbers, and those which have the same base, you're going to add the exponents. Here, if there's no exponent here, there's always an imaginary one. So let's actually perform the operation. So let's multiply the numbers. 2 times 4. That gives me 8. Now when it comes to the exponents, because you're multiplying, you can add the exponents. So that becomes 4 plus 1. So now this becomes 8. K to the 5th. Let's look at another example here. So what do you notice about the variables here? Notice that they do not have the same base. So you cannot multiply, or you cannot add the exponents between them two. So what if you still want to simplify this? You can multiply the numbers. You can always multiply numbers with numbers, but you're not going to be able to combine those variables. So what we have here, we can multiply the numbers. 2 times 3, that gives me 6. And because you cannot combine them, you're just going to put them next to each other. Y to the second, x. You cannot combine the exponents of those two because they do not have the same base. So now what happens if you're simplifying, but now this time we're dividing? Well, like it said on the main idea here, if you're multiplying, you add exponents, and if you're dividing, you subtract the exponents. Now, one thing to keep in mind is that the subtraction happens on the highest exponent. So let's write that down. So the subtraction happens where the highest exponent is located. So here they have the same base. Yes, you're dividing. Okay, so you know you need to subtract the exponents. But where is the highest exponent? C to the 4 on top, C to the 8 on the bottom. The highest exponent, it's in the denominator. So that is where the subtraction is going to take place. So you can bring the C to the bottom. So there's a 1 on top. And then you can apply the subtractions. 8 minus 4. And now that becomes 1 over C to the 4. Again, remember that if we're going to be subtracting, that subtraction is going to happen where the highest exponent is located. So let's do another example here. Let's move 3 here for a second. So now let's concentrate on 2. First, see if you can simplify the numbers. 3 divided by 3, it will cancel out. Now we need to divide those exponents or those expressions with exponents on it. Where's the highest exponent? The highest exponent is on the numerator. So that is where the subtraction is going to take place. So now we're going to have n4 minus 3 divided by 1. So now that becomes n4 minus 3, so that becomes n to the first divided by 1. You don't really have to write that 1, so we can just say that it's n to the first. So let's look at example 3. Example 3, same idea here. Is there a way for us to simplify at least the numbers first? Always concentrate on the numbers first. No, there's nothing I can do with those numbers, so I'm going to keep that 2 there. Now, where is the highest exponent between the variables? The highest exponent happens in the denominator, so that becomes r, 3 minus 2. There's a 1 on top of it. Because if you bring this r to the second to the bottom, there's always going to be a 1 remaining. So now we're going to have 1 over 2, 3 minus 2, so that's r to the first. And lastly, example 4. See if you can simplify the numbers. So I always like to just start with the division sign. Now let's concentrate on the numbers. 18 divided by minus 3, so that's minus 6 on the top because that's where the highest number is located at. And now we have c to the third divided by c to the second. They have the same base, so we can subtract the exponents. But where is the highest exponent located at? The highest exponent is on the top, so that's where the subtraction is going to take place. C, 3 minus 2. And again, we can put it over 1 if everything in the denominator is bring to the top. So now we have negative 6, c to the first, over 1. But we don't really write that over 1, so it's just negative 6, c to the first. So now, here's your entrance ticket. Simplify the following.